my name is Alex. I have some Twitter account. I'm a software developer from Warsaw. And today we will be talking, I will be talking about Sinatra Autopsy. So we will start this with a picture and a question. So the question is, who knows this picture?
No one.
No one, almost no one. Very few of you. This is an anatomy lesson of Dr. Nicholas Tool. It's a painting, it's oil on canvas, frankly, by Rembrandt van Rijn. And in the middle of this painting you can see a body. This one. This guy is definitely dead.
Are you sure?
So this guy is dead, and his name is Aleksander. He lived in Amsterdam in the 17th century, and he was a thief. He was really bad guy because he stole a coat, and I don't know how expensive this coat was, but he did armed robbery on a coat, so probably he kidnapped somebody in some dark place and said, "Hey man, give me your coat," because that was 17th century Amsterdam. And because of that, he was imprisoned and he was committed to death. And they hanged him. Oh no. Because in 17th century, Amsterdam wasn't as liberal as today. Probably. So they were a little bit strict, and probably the crime rate was also lower. And it all happened somewhere in the winter. And because of that, and because of that, it was allowed to perform one public autopsy a year. And the body for a public autopsy should be a body of a criminal. So this way, the bad guy can help other people by giving his body to autopsy after he's dead. So he's contributing. So he contributed to this autopsy, and it all because he died in winter. It happened in January. He was used as a body for autopsy. We didn't have refrigerators back then. And we can see this autopsy here, and we will do something very similar today. So I will look at Sinatra, at internal code of Sinatra, and we will try to find some interesting pieces, some flesh, some blood, some nerves, to see how it's working, and maybe to learn something interesting about Ruby and Sinatra, of course. So why Sinatra? Sinatra has 1,825 lines of code. Of course, it depends how you measure it, and it's like web framework. By the way, who knows Sinatra or at least created once hello world in it? Great, great. So it's really brilliant that you can fit all this code into as many lines of code. For comparison, Rails has almost 100,000 lines of code. It's very hard to count it, but it's something like this. So if you put it into a chart, this is Rails, this is Sinatra, and they both do the same. This is Sinatra. Oh. Tiny. So we will start. So to start autopsy, we have to kill Sinatra. And the whole code is located in only 2 files. There are some other files also, but you can find most of the code in Sinatra base and Sinatra main. If you are somewhere in the back and can't see the slides, you can go here. There will be some code, there will be a lot of code, but don't worry, we'll go through it. It won't be so hard, I hope. So routing, that's probably my favorite thing in Sinatra. You can see this get do something, render some index, and when there is a post to orders path, create some order with given ID, and then render order partial. And this looks pretty amazing because it doesn't look like a code. It looks like DSL, domain syntax language. But there are no magic in it, because if we put brackets, we will see it's simple Ruby code. So we have method get with argument slash, and then we pass block to that method, and in that block we call method called haml with argument index, and the same thing with post. So we call method called post with some argument, we pass some block into this post, and we call some Ruby code. No magic. And this get and post, if we look at this Sinatra base, we will see methods define them. Exactly, we will see this get, put, post, delete, head options, and even patch. So all these lines, they look pretty. This is how it is exactly in Sinatra. So it's nicely aligned. Let's take post, and it's hard to read like this, so maybe we'll write it in normal way. So when you call a post, you are just calling method called root with argument post, and you're passing path options and so on. If you call get, the same thing is happening. So these all methods do the same. They point to root, except get. I'm not sure why. I probably have to ask Konstantin why, because it defines get and head for it, so 2 roots instead of 1. So let's go back to this post. And the important thing is this root method, so let's go to the root method. When you are investigating somebody's code, it's like Inception. You have to go deeper, 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 deeper. So we have to go deeper to root. It's a little more complicated here, this method. And what is interesting here? The most interesting thing here is this signature. So there is another method, we won't go into it, called compile, which gets the verb, which gets the path, block, and options, and it creates method, and it's create the root, and that root is put into roots into the next line. So, okay, let's go to this compile. Again, this is where the meat is, the flash. So there are some options, method name, unbound name. Again, what interesting is here, unbound method, generate method. So again, we have to go deeper. And generate method is very clever. Here where cleverness is. First of all, the method is defined with a method name and a block. It's normal normal dynamic thing in Ruby that you can define method whenever you want. In second line, there is instance of that method is created, and this instance is assigned to variable called method. So under variable you have a method, because method is a Ruby object, like everything in Ruby. And the third line is very tricky, because this method is removed, undefined method. But we have instance of that method bound to this method variable, and we can pass it back. So you cannot call this method from a class, but you can call this method using this variable. So you can call this variable. So the method is created. The method is defined in first line. The method is assigned to variable in the second line, and the method is undefined in the third line. So that's quite tricky. And at the end, this method simply is put into roots. We were talking about this guy, and now we will be talking about Dr. Nicholas Tulp. I cannot talk about code for 40 minutes because you would kill me. So we will, in the breaks, we will talk about this painting. So I hope you won't get bored. So this is Dr. Nicholas Tulp, and he had the most awesome title ever. His title was Prelector Anatomy at the Guild of Surgeons. So his card must look great. Oh, your Prelector Anatomy of Guild of Surgeons. I wish programmers had their guild. How awesome that would be on a card. Guild of Ruby developers. I think we should start one guild. So he was a doctor. He was conducting this anatomy session once a year, and not only was he a doctor, he was also a city treasurer 8 times. And what's more, he has been Burgomaster of Amsterdam, some kind of a mayor, 4 times. So he was more like a politician, not a doctor. And he had 36 years when he ordered this painting. He paid Rembrandt to paint this painting. And all these people, there are no doctors. They are simply rich, middle-class citizens of Amsterdam. Only 2 of them are physicists. Rest of them are just some rich guys who wanted to be on this picture, and who wanted to see what is inside the body. Because it wasn't, they didn't have internet, they couldn't download the picture of a hair or other things. Okay. So, yeah. You can't read it, I won't read it either. This is the method I found inside. When you look into the body, you will sometimes find something like this. And I'm not sure whether I like it, this code. I don't think it's so smart. Or maybe it's too smart. So, it's start of this method. Again, I will break it a little. So, we have a method called set. And we have some option and value. And this value is not set, true. Oh my god. When you look at this code first time, it's really tricky. Not set equals true equals value. Of course, you can write code like this. And probably sometimes you have to write code like this. But unless you are doing some tricky thing, I think you shouldn't. I think that it should be refactored to something more readable. So it's a matter of squishing 2 lines of code into one. And here it's even more strange. Raise argument error if block and not set. It's double negation here. So we have not set, and this not set is false. So why isn't it called set, or maybe unless used here? I don't like it. And again, value not set equals block false if block. At first you might think whether this false is assigned to not set if block exists, or the whole expression. Of course it's tricky, and if you think a little, you will understand what's the purpose of this code. But you could break it into 3 lines of code. They would be very simple and very easy to understand, and what's moreover, very easy to maintain. So that's again true. But because Sinatra has only less than 2,000 lines of code, you have to do tricks like this to achieve this kind of size. This is tricky. So there are 2 procs. One of them is assigned to setter variable, and second one is to getter. Obviously, the first one sets value using this block, and the second one is retrieving the value from this proc. And this proc is put into this singleton methods, setter and getter. So whenever somebody is calling, for example, you can call this method set with run. So value will be run, and if value is run, you can assign value equals something and get the value of this value. Okay. That wasn't so pleasant, but there is some sugar inside Sinatra. And sugar, people from other languages like to say that Ruby has syntactic sugar. So these small bytes of code which makes our life easier. I don't think it's syntactic sugar, I think it's just good practice. So look at this. There's a method called back, very tiny method. It doesn't do anything. It gets only repairer of a request. But how far better is to write in your code back instead of request referrer? It's much shorter, it's much more easier to understand it. What's more, there are methods for status of a request. So if code of a status is between 200 and 299, that means the request was success. And of course, you don't have to define this method called success, redirect, but how easy your life is when you have these methods. It's only a few lines of code, but instead of putting into your code, oh, status is bigger than 200, you just type success, is success, if success. And the same thing is for client error, server error, and even not found. Not found is very popular in popular error. It happened. So this status is probably the most useful. So it has its own method. It again doesn't do a lot. It checks whether status is 404, but it makes the code better when you read not found instead of the status. All of you know this status code, or for at least 404 and 200, but it's much better to use the names. So that's the thing I like in Ruby, because you can add the syntactic sugar very easily, and and use it. And it's not syntactic sugar, it's just good practice. And templates. In Sinatra you can define, for example, get template with a ham or ERB or SAS or whatever. And these methods are again very simple. So there is method for ham, there is method for liquid, markdown, textile, and RDoc. And they all call method called render, which renders the whole template, get partial, get layout. And isn't it redundancy? What if we could try it a little? Because there are 20 templates, template engines in Sinatra, and they all could be fit in very smaller piece of code. So, for example, we can get an array of ham, liquid, SAS, and so on, and we can iterate through these names and define a method for each of these templates with a name. So it will be ham, it will be liquid, and so on, with some options for that method, and call render name to symbol. And these 5 lines of code would do exactly the same what 20 or even more is doing. So you can squeeze a lot of code in this instead of the second one. So who prefers define method? Here? Okay. Who prefers normal defining method? Okay. The rest doesn't hear me? Okay. So here I think, okay, you could use this define method, but when you're reading somebody else's code, it's much easier to just see, oh, it renders template for ham. Oh, it renders template for liquid. But in the first example, you have to think about this code, and when you have to think about somebody's code, that's not so good. Unless you are I don't know, some algorithmic context. But when you are working, you just want to get shit done. You don't want to think, what is it? Define method. When you can choose simpler solution, you should follow it. It's like Occam razors. And what's more, for example, SAS and builders have some options inside of it. So anyway, you have to write them like this. So why would you have some methods in using this define method and some method like this? That would make no sense. Rembrandt's anatomy lesson, yes, I too was stunned. Do you remember the flesh tones? Earth, bare earth, especially the feet. Also, there is sometimes always really a contrast between the tone of the dress and that of the face. These are the works of Vincent van Gogh. So he also was studying this picture, and he wrote it to his brother. He's talking about chiaroscuro. Who knows this term? Yeah, me too. So you learned something today? Chiaroscuro is an Italian word for painting when you have huge contrast between the dark and the white. So chiaro means bright, and scuro means dark. So chiaroscuro was used on this picture. And you can see all these people, they are well dressed, at least using terms of 17th century. They are today they would probably be in a suit. So they have this, I don't know how you call it, this strange dress, and it looks so fear. But their faces, they are really interested in it. They are looking at it. They are curious. They are really surprised. Oh my God, what's it? Sinatra, of course, has some tests. And when you're developing open software, you have to write tests, otherwise people will boo at you, write a blog post and say, oh, your software sucks because it lacks a test. So Sinatra has more than 8,000 lines of tests. It's 4 to 5 for each line of code, so it's plenty of it. So there is mostly tests for everything. We will look at one of these. And some of them are smart, like this one. Okay, let's break it. So we have verbs like get, put, post, delete, options, and patch. So there is an array of these verbs, and we're iterating through this array. And for each verb, there is defined aspect. It defines get request handler with get. It defines post request handler with post. And for each of these, there is mocked up with this variable, so with this verb. So again, you will have get, hello, post, hello, and so on for each test. And then there is a response that there is a request using that verb. Because all these tests are simply checking whether this verb is working with some simple root. So instead of writing get, put, post, delete, options, patch, 5 or 6 methods, you only type it one, and you don't have to copy and paste this stupid code here for a test. There's a difference between this, because it's test, and the code we were looking at with templates. Because here it's just a test, so it's not a part of an API. So it's for internal purpose, and I think this optimization is pretty clever. How do we know this is a Rembrandt's painting? We can okay, if we were art students, we would say, oh, of course, because it's chiaroscuro and it's Rembrandt and so on. But oh my God, you can see it here. You can see it, but here there is typed Rembrandt and the date, 16th century 32. So Rembrandt did a mark on this painting, and when he was painting this, he was 26. Can you believe it? He was 26 years old. Who here has less or equal than 26 years? Oh, a lot of you. So you still have your chance to paint the anatomy lesson. You're not lost. You still can have. You can still achieve something. And that was Rembrandt's second year in Amsterdam. He was discovered by Huygens, this Huygens, physicist, and Huygens brought Rembrandt to Amsterdam, and Rembrandt started to build his own mark, his own brand, and he was very good painter, but he wasn't anatomist or physicist. He was a son of Miller, but he was quite well educated. He finished the school and even attended to the university. That was 17th century, so that's cool. But he didn't quite understand what he was painting, because all this public autopsy, they all started with a belly. So all what is interesting was here. And that would be much more brutal if Rembrandt would paint it as it was. So he didn't want to shock anybody, so he just painted this hand. And also the gesture of Dr. Tulp is not like anatomy, it's just explaining something. But even though Rembrandt didn't know a lot about anatomy, he could portray this exact moment of autopsy and the whole excitement and curiosity on it. So this is the simplest Sinatra app, and probably this is the most interesting thing in Sinatra. This maybe most magic. You type require Sinatra, add this get high and hello world, and then you run this file. Just type ruby hello world.rb and it's working. But you only define some roots. How is it working? Is it working because of the second file? We were looking at Sinatra base so far, but there is the second file, Sinatra main, and this is this file. So we can start very slowly. So it loads Sinatra base. So far so good. And there is modulo Sinatra and application plus OK. And then, using this set method we were discussing earlier, app file is set. And app file here is set to color files first. What is color files? Again, we have to go deeper. If you want to understand some code, you have to go deeper. So let's find color files, and we see color files called cleaned color 1 flat. Again, deeper. And this cleaned color doesn't look so clean. And the comment is even appropriate. It's like kernel color, but excluding certain magic entries. And the important thing here is this color thing. The rest is just magic, but we have this color. Who knows method called color in Ruby? I didn't know this method even exists before I dig into this code. So in kernel of Ruby, so in the very own core, there's a method called color. And what is it doing? Let's take this code. We have two methods: A method which calls color, and B method which calls A method. I know, not so clever. And then we call this B method. So the result of this program will be backtrace. So we will see that at the beginning, in a main, there was something called, and then in a sixth line, the B was called, and then in a second line, the A. So we have backtrace using this method called color. There is some argument 0. 0 means how many lines from bottom or from the top here should we skip. So if we pass 1 instead of 0, it will omit the first line. If we pass 2, it will omit the last line. So this color files first give us simply the file name. And that's almost the same thing which gives us the $0. Who knows $0? Oh, even better. So that will give us the argument for Ruby, so which is file name by default. And if this file with Sinatra application with this root has been called directly, the run will be set to true. Otherwise, if it has been run as a test or from somewhere else, it won't run. So there is run set. And at the end of this main file, there is this. This is the magic line. This at exit application run if $!.new. Oh my god, $!.new. What is it? Wow, cool. I didn't know about it either. I'm really impressed because it's exception, information about an error, and this line simply checks whether there has been some error. And there are a lot of predefined variables in Ruby. I didn't know about them before. Like, you can set default field separator. You can set default output. It's std out here. You can even get process ID. And there's about 20 or 30 variables like this. So at exit is a code which is called at the end of everything. So if there was no error and the application is set to run, which means that the file with this application was called directly, run this application. So because in your file you required Sinatra and that was loaded, it will start your application after processing all your files magically. So we were looking today at Sinatra, at some smart things and tricky things and bad parts. So even in Sinatra there's messy code. You remember this set methods with this not set negation. But the most of this application is Sinatra is written pretty straightforward, like these templates, like these roots. They are explicitly defined, so it's easier to understand. And I think what the lesson is today, except of chiaroscuro, is that you should try to write your code to be dumb, so not so clever. If you write something explicitly, a lot of short methods, it will be easy to understand and easy to read. You can find this. Autopsy